encoders and its applications. Let's explore the slides. So basically position encoders are used to track the rotary position of shaft or linear position of a load. It can be either mounted on that load or it can be mounted on the shaft for the position measurements. For linear position encoders, there are three basic approaches for tracking the positions. So in this upcoming slides, we are going to see about the linear position encoders and how the position is measured by using the linear position encoders. So there are three measurements techniques: indirect measurement technique using rotary motor, indirect measurement technique using a linear motor, linear and linear encoder, and direct readout of position encoder on the load. Let's see how measurement are done by using the position encoder. So this is the indirect measurement using position encoder on a rotary motor. Here we are using a rotary motor for measurement of position. A rotary position encoder is installed on the shaft of the rotary motor to monitor the shaft position. And here position encoder provides an output corresponding to the rotation of the rotary motor. So voltage pulses are given as an output when we are using the incremental encoders for measuring the position. Or suppose if it is absolute angular position encoders are used, absolute angular position is given as the output as for observing the position. So the readout device where it is a controller, drive or a counter display which needs to convert the pulses which is received from the encoders, and it can be converted in terms of length of travel from initial position to final position, and place of that particular load where it is located. Like that we can have the details from using the position encoder in indirect measure. So the decision of whether we are using incremental position encoder or absolute position encoder is determined based on the application we are choosing. Suppose if your need for an application incremental encoder means we can go with incremental encoder. Suppose if an application needs absolute encoder means we can go with absolute encoder. For example, if you are taking surgical robots as an application, here the starting position should be in the area where especially after a fault while performing the surgery. So in other cases, we can start with any position. So this is not a problem. So this configuration of position encoder is very easy to install, and it is more reliable, and also it supports a direct feedback to the motor. The position encoder is not directly connected to the load. However, this method provides some limited accuracy only. We cannot use this method. We cannot suggest this method for many applications. What are the basic error sources means? So when we are coupling, there is an error source for while taking the reading, and shaft to shaft misalignment is there. So it also gives some error reading. Gearbox backslash is also giving some error reading while taking the measurement. Non-linearity is introduced while acceleration, and also environmental conditions like temperature variations, etc. These are some of the sources of error which will not give an accuracy of measurement. So we are saying as it offers limited accuracy only. In application requiring reversal of directions, hysteresis can be the problem. So particularly when there is a significant amount of complaints in the system. Next, we are going to see about the indirect measurement using a linear encoder on a linear motor. So previously we have seen rotary motor with some position encoder. So here we are going with linear encoder. You can see the image which is given as linear encoder is mounted with linear scale, and the motor is there. Here this is nothing but load which will be moved in a linear scale. So here the monitoring of motion of that linear motor with linear position encoder delivers better accuracy compared to that of the indirect measurement in rotary shaft encoder. Here it generates linear motion directly. There is no need for mechanical actuator also. So this eliminates major error, and we can have an accurate measurement. To measure the position of the load, a linear motor with linear encoder and also is placed on a linear scale, which is affixed to a stationary part of the motor. Typically, magnetic track is used on the surface for supporting it. The readout element of the encoder is mounted on the moving part of the motor, which is known as forcer, for having an accurate readout for the user side. Here also we can choose either of encoders, either we can choose incremental or absolute and position encoders based on the applications. So here the readout device with the measure of displacement that can be used to calculate the position of the load. An example of this indirect rotary encoder method is to use a drawstring encoder. This is a we commonly call it as hydraulic cylinders. This method provides better accuracy compared to that of the rotary encoders, and it must be used in an appropriate environment to have an accuracy in measurement. So it needs to be properly mounted so that it should be properly aligned for getting good accuracy in taking readings. Next, we will go for the direct measurement of a position encoder on load. So the diagram which is shown here, you can see the motor on linear scale and linear encoder which is fixed on the linear scale. Applications requiring very high accuracy, we can go with the linear encoders mounted on the load. This direct readout method generally reduces the measurement error. It can be used with both linear motors and also rotary motors driving on linear actuators. This approach, we are having linear position encoder should be mounted externally to the linear motor, or it can be connected with actuator. You can have look at that image. We are having that linear scale and linear encoder which is mounted on that. The linear encoder which will give high accuracy here. The scale of the linear encoder should be mounted to the non-moving surface so that the detector assembly can detect the position of the load, and it can be affixed to any part of the linear scale. So particularly, for example, the ball screw actuator mounting the encoder on the load removes much of error in the system. Here, the encoders typically outperform most system components, and direct approach makes it easier to achieve accuracy and repeatability necessary for application requirements. This technique is best suitable with incremental or absolute errors because of direct measurement. Here, incremental encoders can be used with interpolation techniques for getting high accuracy and high resolution, while absolute position encoders versions have the advantage of reading out the position of direct loading and where the load is placed directly. One example of very high resolution device that has been employed in configuration is a laser interferometer, which gives best example for incremental encoders interpolation technique. Let's go with the application. So there are more number of position encoders application. So I'm limited here, and it can be used for surgical robotics, microelectronics, diagnostic imaging systems, oil and gas, home assistant robots, photonics, medical equipment, radiation therapy, renewable energy systems, and industrial robotics, satellite communications. Likewise, it will be going on where we can have position measurements, accurate position measurements based on the type of encoders we are choosing for the particular applications. Right. Thank you for listening. These are the references. Thank you for watching. Thank you.